So the learning objectives for today. Recall that the current depends on both resistance and potential difference and the units in which these are measured. So what is the definition of potential difference? Recall and apply the relationship between I, R, and V, and that for some resistors the value of R remains constant, but that in others it can change as the current changes. Explain that for some resistors the value of R remains constant, but that in others it can change as the current changes. And P3.2F, explain the design and use of circuits to explore such effects. So we'll be looking at wires, filament lamps, diodes, NTC thermistors, and LDRs. So what is voltage? Well, the equation for voltage is energy per unit charge. So V is equal to E over Q, and voltage is measured in volts, energy is measured in joules, and charge is measured in coulombs. So voltage is how much energy you apply to either a collection of charges or a single charge. So that's the definition of voltage. Voltage is energy per charge. What is Ohm's law? Now, Ohm's law says that as you increase the voltage, you increase the current as long as the resistance stays the same and assuming that the temperature is staying the same. So voltage is current times resistance, where the resistance and the temperature are constant. V is equal to I times R. That's Ohm's law. Okay, so on the right hand side, you've got a curve. On the left hand side, you have a straight line. So here, if you look, because it's a straight line, here we can say that V is equal to I times R. So in this case, the resistance stays the same and the current will increase as you increase voltage. So as voltage goes up, then the current also goes up. So as voltage goes up, then the current goes up. So for the ohmic means that it obeys Ohm's law. So if it's ohmic, it means that it obeys Ohm's law. But if you look at the filament lamp, the filament lamp is non-ohmic. So in this region here and in this region here, it does not obey. So it does not obey Ohm's law. So in this case, V is not equal to IR. Okay, so the filament lamp, the resistance of a filament lamp increases as the temperature of the filament increases. Reversing the potential difference, negative values on the graph, reverses the direction of the electric current, but does not change the shape of the curve. So again, this is non-ohmic. Because remember, the ohmic is a straight line. Right, so that's straight line. And for this is a curve. So here is when the resistance is high. So that's when R is high. Now there is an equation relating resistance, length, area, and resistivity. So R, the resistance, is equal to rho times L divided by A. So as length increases, the resistance will increase. However, as the cross-sectional area increases, the resistance will decrease because you're making more space for the electrons to move around. In this case, R, the resistivity, so the symbol for resistivity is rho, and in this case the resistivity is proportional to T. So resistivity is proportional to T. And since resistivity is proportional to T, resistance is also proportional to a rho. So here you got the equation R is equal to rho times L of A. Resistance is proportional to the length and resistivity of the metal. Now, copper will have a low resistivity. So copper will have a low resistivity. That's rho, right? So resistivity have a low has a low resistance. A high resistivity, for example, would be plastic and insulator. So metal conductors have low resistivity. The longer the length, the more likely the electrons will collide. More surface area means less resistance. This should say cross-sectional area. So it's more cross-sectional area rather than surface area. It means less resistance because electrons can flow more easily. Okay, this is a IV graph for a diode. Not a diode, but for a semiconductor. So, for example, a thermistor or an LDR. So, if you look in this region, here the resistance is high. So here the resistance is high, but for this region, it is low. So R is low. So resistance is low. So the resistance is low. Now that is because as you increase voltage, the I goes high very quickly. So if I do a here, so here there's current I, and here it's voltage V. So for a small increase in voltage, you have a high increase in current. And here for a high voltage, you have a low current gain. Okay, so current through a resistor is directly proportional to the potential difference. So this is for a normal ohmic resistor. So a normal resistor, the resistance is constant, such a resistor is called an ohmic conductor. So if it's an ohmic conductor, it will obey V is equal to IR. So R is a constant. So R is a constant. The current through a filament lamp is not directly proportional to the potential difference. This is because the filament gets hot, which causes the resistance to increase. At high temperatures, the atoms in the filament vibrate more. The electrons in the current now collide more with the atoms. More energy is needed to push the current through the filament. As the potential difference increases, the current no longer increases as much. So on the right hand side, this is the V is equal to IR graph. So this is when it obeys Ohm's law. So let's work out the gradient. So in this case, the gradient would be 1.6 minus 0.4. Which is 1.2. And the dx is 9. So the gradient will be 1.2 divided by 9. So the gradient we got as a 0.13. And however, because here it says it's I over V, however, we need V over I to get R. So the gradient is I over V, but we need V over I. So we need to flip the fraction upside down. So to flip the fraction upside down, we need to do 1 divided by 0.133 recurring, and then you should get R as 7.5. So R is equal to 7.5 ohms. So if we look at these two non-ohmic devices, so these non-ohmic devices, where it does not obey Ohm's law, so where V is not equal to IR, so as temperature goes up, the resistance goes down. And here, as light intensity goes up, similarly, the resistance goes down. So as light intensity goes up, then the resistance will go down. Make sure you remember these graphs. So as the temperature goes up, the resistance goes down. As the light intensity goes up, the resistance also goes down. Now the symbol for diode is you have a triangle pointing towards the conventional current, and you have a line at the end of the arrow. So that is for a diode. So that's a diode. However, the one on the left is a light emitting diode. So this is LED, because that is the thing that's emitting the light. So the thing that's emitting the light is called the LED, and the one on the right hand side is the diode, and it is made of a semiconductor. Okay, so what are the IV characteristics for a diode? Now, it is again a non-ohmic, meaning it does not obey V equals IR, it is not a straight line, so the resistance of a diode is not a constant. Let's carry on. So here, if you did have a negative, it would go in this direction. So very little current will go through. And then here, the 0.7 is the threshold voltage. At this point, the resistance becomes very, very low. So at this point, the resistance becomes very low. So the resistance becomes very low after the threshold voltage. So if you look at the left-hand side diagram, this has to go in the conventional current. So this has to be in a conventional current. And only then will this light bulb work. Conventional current is from positive to negative. So positive to negative, and it's going in this direction, the conventional current. This one does not work. It will be the reverse bias. So this is called the reverse bias. Okay, so how would you do an experiment with LDRs? So here you would vary the distance with a light source. How do you reduce other background light? Well, you need to have a darkened room. If the light source is further away from the LDR, light intensity is less. So what would your graph look like? So let's just say that this is the distance from the light source, and this is the resistance. The further away you are, the higher the resistance, and then the closer you are, the lower the resistance. So it could be something like a curve, or you might even get a straight line, but this will be a positive relationship. So this will be a positive relationship. So as the distance from the LDR increases, the light source is further away, the resistance will increase.